Today we're going to review how to solve systems of linear equations algebraically. We're going to review the two methods that we learned, which are elimination and substitution. We'll start with elimination. So we're going to look at a system of equations. Our system is 3x plus 2y equals 8, and x minus y equals 1. So at step one, it says, look at the equations. Are they both in standard form? So think about elimination. Elimination, we want both variables to be on the same side together. We want them to line up, and we are trying to look for opposites. So that's why this question asks you, are they both in standard form? Because that indicates to us that elimination is the best method to choose. They are both in standard form. The variables are on the same side together. So we are going to go over to the yes side and take a look at step 2. It says, look at the equations. Are there any equal and opposite variables, like 3x and negative 3x? So here in this step, we look for opposites. 3x and x are not opposites. 2y and negative 1y are not opposites. So here we're going to put no. We have no opposites, which means we're going to follow this step. So it says multiply the equations. Multiply one or both equations by a non-zero number to create a pair of equal and opposite variables. So I'm going to rewrite our system here. 3x plus 2y equals 8, and x minus y equals 1. And we are going to create opposites. Now I have some choices. I can get rid of x's. Since I already have a 3x, I would want to make sure in the other equation I had negative 3x. Or I can get rid of y's. Since I have a 2y in the first equation, I would want the other equation to be negative 2y. So I'm going to choose to get rid of the y's. So I'm going to take the bottom equation and I'm going to multiply it by a positive 2. Because if I do that, when I multiply 2 times negative y, I'm going to get negative 2y, which will be the opposite of positive 2y in the first equation. Now remember, when you pick that, you need to multiply all the pieces of that equation by that number. So our new system is 3x plus 2y equals 8. But our second equation is now 2x minus 2y equals 2. So now we can follow our next step to step 3. We're going to add together the two equations to make a single equation with one variable. So now that we created opposites, we can take those two and we can add them together. So 3x and 2x makes 5x. The whole reason we multiplied by 2 was to make opposites so that 2y and negative 2y would completely cancel out, and then 8 plus 2 makes 10. So now following down to step 4, it says solve the equation from step 3. Well, we have the equation 5x equals 10, which means I need to divide both sides by 5 to get x alone, and that means x equals 2. But remember back to when we're graphing systems that our answer should always be a coordinate. It's an x-y combination that makes the equation true. So now that we've found x, we also need to go forth and find the other variable. So we're going to substitute the value of x that we already found into one of the equations. It does not matter which one you choose in order to find the other variable. So I decided to pick the x minus y equals 1 equation. Again, you can pick either one. We just found out that x was 2, so I'm going to substitute that in. And then we're going to solve this equation. I need to get rid of the 2 by doing the opposite, which is subtracting. Now be careful here. I picked this equation on purpose because I do notice there's a lot of errors in this step. There is a negative y left over. So the negative and the y must come down. And then 1 take away 2 would be negative 1. If you forget to drop that negative, you won't see that there's actually a second step of having to divide by negative 1. When we divide by negative 1, we see that y is equal to 1. So right now we think the answer is 2, 1, an x value of 2, a y value of 1. But we won't know for sure until we go do our check. So our final step is our check. Notice again it's split into two sides because it has to check in both equations and work for both of them at the same time. So we'll start with 3x plus 2y equals 8. My x value is a 2, so I'm going to subs that in using parentheses, and my y value is a 1. So 3 times 2 is 6, 2 times 1 is 2, and then 6 plus 2 is 8. So it does check in the first equation. Our second equation is x minus y equals 1. Our x value is 2. Our y value is 1. So I have 2 take away 1, which is indeed 1. So now that we know it checks in both, I am definitely positive that my solution is an x value of 2 and a y value of 1. So we will write it as a coordinate 2, 1, and we can circle that as our final answer. Now let's move on and practice solving one algebraically using our substitution method. So our system for this one is x plus 2y equals 5 and y equals 2 minus x. So for this one, we want to make sure we have one equation at least where one of the variables is isolated. So when I look at this system, I see that we have this one right here that I'm starring in green, where y is totally by itself and isolated. Okay, so our answer to this is actually yes. We are all set to go. So it says substitute the expression for the isolated variable into the other equation and solve for whatever's left over. So if I go look at this, they're telling me that y is equal to 2 minus x. That means that I'm going to take the 2 minus x and I am going to substitute it into the other equation in y's spot because that's what y equals. So this first equation is going to become, we'll rewrite it here. So remember what I did, x plus 2y equals 5, and we had y equals 2 minus x. So 2 minus x is going to go in the other equation in y's spot. So what happens is the equation that was x plus 2y is now going to become x plus 2 times 2 minus x equals 5. And now we have an equation with one variable that we can solve. So follow your steps. First, we're going to look for a distributive property, which we do have. So I would have x plus 4, because 2 times 2 is 4, and 2 times negative x would be negative 2x. After distributive property, I look for like terms. On the left-hand side, we do have like terms of x and negative 2x. So if I combine x and negative 2x, I get negative x plus 4. And on the right side, we don't have any like terms. So now I'm going to have to get x by itself by undoing my addition and subtracting 4 from both sides. I have negative x equals 1. And so I need x to be alone. There's really a negative 1 in front of that, so I'm going to divide both sides by negative 1. So I get that x equals negative 1. Now, as we talked about previously, our answer should be a coordinate. So moving on to step 3, we're going to substitute the variable from step 2, which is x equals negative 1, into the equation with the isolated variable. Now, technically, you can pick either one you want, but they're telling you to pick the isolated one because it's the easiest one to use. If you plug into the isolated equation, you don't have to solve anything, you just have to simplify the math. If you were to use the top equation, you'd have to do much more work. So here, we're going to use the y equals 2 minus x. We already know that x is negative 1, so this is going to be y equals 2. Now, careful here. There's a subtraction in the problem, and then I'm putting in a negative 1 for x using my parentheses. So that means y equals 2 plus 1, because that double negative is going to create a positive, and that means my y value is a 3. So then we're going to head over to step 4, check our solutions. So we believe x is -1 and y is 3. Again, notice the 2 checks, one for each equation. We'll start with the x plus 2y equals 5. We know that x is -1 and y is 3. So we'll substitute those in, making sure we use parentheses. So I get -1, 2 times 3 is 6. So plus 6 equals 5. And -1 plus 6 really is 5. So it checks. On the other side, we have y equals 2 minus x. We know that y is 3, and we know that x is -1. So we end up with 3 equals, the double negatives is going to make this 2 plus 1, and therefore 3 equals 3. So since it checks in both, we know for sure that our answer is -1, 3, written as a coordinate. And that concludes our lesson on reviewing the Chapter 5 concepts, Day 2.